So let's solve this question of limiting factor. Again, pause the video, read the question, and we will get started together. Now, assuming you have read the question, so you must have realized the machine hours are the limiting factor because we have a limit of 10,000 machine hours per month, and there's no demand limit. So that means we could have made as many as we would have liked, because if there was a demand limit, then we would have to see to meet the demand how many hours do I need. In this question, we don't have a demand limit, means whatever we don't have like unlimited amounts of, that's a limiting factor in this type of question. So why don't I copy the format that I already showed you and show you, like that is a great way to solve any limiting factor question. So let me paste the steps. There we go. Okay, so what is the first step? Determine the limiting factor. We know limiting factor is the machine hours. So step one, finished. Step two, calculate the contribution margin per unit of each product. So let's do that. So I will always recommend writing the products into columns like I always do, and beta the other product into the column as well. Okay, so now we have to find the contribution margin per unit of each product. For alpha, the contribution margin per unit would be sales price minus variable cost. So 60 minus 36 would be 24. And for beta, we have 50 minus 30, so 20. Done. Step 2 also finished. So step 3, calculate the contribution margin per limiting factor used for each product. So I already gave a formula for that, how to do that. So contribution margin per limiting factor, in this case per machine hour. So formula is very simple. You divide the contribution margin per unit with the limiting factor used per unit. So let's see how many machine hours we are using per unit. For alpha, 3 hours. So we'll divide this by 3. There we go. That means for every 1 machine hour, alpha is giving us the contribution margin of $8. Okay, similar with beta, we'll divide its contribution margin per unit by the limiting factor it's using per unit, which is 2 hours. So divide it by 2. So third step also finished. Fourth step, rank the products according to the contribution margin per limiting factor. So if you can see which has a higher contribution margin per machine hour, of course the product beta. So according to the ranking, we will be making product beta first. And if we have, let's say, met the demand of product beta and we have some machine hours left over, we'll use those remaining hours on alpha. But in this question, of course, we don't have a demand limit. So whatever machine hours we have, we'll just keep making the product beta and just keep going. So what was the requirements? Requirements were determine which product should be prioritized. We already know we should be making the beta product and prioritize that to maximize profit, assuming machine hours are only limiting factor. Okay. If speed tech can produce either product, how many units of each should it produce to maximize profit using all of the machine hours? So now we have to determine with 10,000 machine hours, how many units of beta can we make? So the formula is very simple. You divide the total limiting factor by the per unit requirement. So in this case, we'll do total machine hours divided by how much machine hours we need per unit of beta, which is 2 hours. So that means we would be able to make, or we should make, 5,000 units of the product beta. And that's it. That's how you make the limiting factor decision. Just like follow the steps, and I hope you're seeing that's very easy to solve as long as you know the steps. If you don't know the steps, again, as I always say, you just wander around, look for extra information. Should I care about this? Should I care about that? You don't need to do that when you know the steps. You know exactly what you're looking for. So that's it for this video, and I will see you in the next one.